Black holes are cosmic giants that break every rule we know about space and time. From swallowing light to stretching time itself, these mysterious objects have puzzled scientists for decades. Let's explore their strangest secrets together. When massive stars run out of fuel, they put on the universe's most spectacular farewell show. Stars at least 20 times bigger than our Sun face a dramatic ending. Their core collapses while their outer layers explode in a massive supernova. What's left behind is a point of infinite density called a singularity. The star's intense gravity becomes so strong that it creates a boundary in space called the event horizon. Think of it as a cosmic point of no return. Anything that crosses this boundary can never escape, not even light itself. This process happens in just a few seconds, but it creates an object so powerful it can bend the fabric of space and time. The bigger the dying star, the larger the black hole it leaves behind. Some can be as small as a city, while others grow to be millions of times more massive than our Sun. The event horizon is like a cosmic fence around a black hole. It's the line where gravity becomes so strong that nothing can break free. When something crosses this boundary, it's pulled in faster than the speed of light, which is why we can't see inside a black hole. Think about throwing a tennis ball up in the air. Normally it comes back down because of Earth's gravity. Near a black hole, the gravity is so powerful that even if you threw that ball at the speed of light, it would still fall in. This incredible force affects everything around it, even time itself. The closer you get to the event horizon, the slower time moves compared to someone watching from far away. If you could watch someone fall into a black hole, they would appear to slow down and freeze in time at the edge of the event horizon. Here's where things get really weird. Black holes don't just bend space, they twist time itself. The closer you get to a black hole, the slower time moves for you compared to someone far away. Imagine you're an astronaut brave enough to visit a black hole. As you approach it, every minute for you might be hours or even years for your friends back on Earth. This isn't science fiction. It's a real effect called time dilation, proven by Einstein's theories. If you were watching a friend fall toward a black hole through a telescope, they would appear to move slower and slower, eventually seeming to freeze in place at the event horizon. Meanwhile, from their perspective, time would feel completely normal. It's like being in two different time zones, but instead of a few hours difference, we're talking about years or even centuries. When objects fall into a black hole, they experience something scientists call spaghettification. And yes, it's exactly what it sounds like. The black hole's gravity becomes so strong that it pulls harder on the front of an object than its back, stretching it out like a piece of spaghetti. If an astronaut fell into a black hole feet first, their feet would feel a much stronger gravitational pull than their head. This difference in force would stretch them out, getting thinner and longer, like pulling taffy. The same thing happens to stars when they get too close. They're pulled apart into long, thin streams of gas and dust. Even something as solid as a planet would be stretched and squeezed until it's torn apart. This process shows just how powerful a black hole's gravity really is. It can take any object, no matter how strong, and pull it apart atom by atom. At the heart of nearly every galaxy, including our own Milky Way, lies a monster, a supermassive black hole millions or even billions of times heavier than our Sun. These cosmic giants shape entire galaxies around them like cosmic architects. Our galaxy's black hole, called Sagittarius AI, weighs about 4 million times more than our Sun, but it's actually quite small compared to others out there. The largest known supermassive black hole is 66 billion times the mass of our Sun. That's about 15 times the weight of our entire solar system. These massive objects act like cosmic vacuum cleaners, pulling in gas, dust, and even entire stars, creating bright disks of material around them that we can see from Earth. Scientists are still trying to figure out exactly how these giants formed so early in the universe's history. In 1974, Stephen Hawking made a groundbreaking discovery that changed how we think about black holes. They're not completely black after all. He showed that black holes actually leak tiny amounts of energy, now called Hawking radiation. This happens because of weird quantum effects at the edge of black holes, where pairs of particles pop in and out of existence. When this happens near the event horizon, sometimes one particle escapes while its partner falls in. Over incredibly long periods, we're talking longer than the current age of the universe, this causes black holes to slowly lose mass and eventually disappear. For small black holes, this process happens faster, while massive ones take much longer to evaporate. It's like a cosmic bathtub with a very, very slow drain. When things fall into a black hole, we face a fascinating puzzle that even stumped Einstein. What happens to all the information about those objects? According to quantum physics, information can't be destroyed, but black holes seem to break this rule. When something falls in, all its details, its color, shape, and what it's made of, appear to vanish completely. Scientists call this the information paradox. Some think the information might be stored on the black hole's surface, like a 3D hologram on a 2D screen. Others suggest it could leak out through Hawking radiation, or maybe it creates a copy of itself in another universe. It's like throwing a book into a fire. The pages burn up, but the information about what made that book should still exist somewhere in the universe. Now let's explore some of the most fascinating ideas in physics: wormholes and white holes. While black holes pull everything in, scientists think there might be opposite structures called white holes that only push things out. Between them could be tunnels through space-time called wormholes. Think of space as a piece of paper. If you fold it and poke a hole through both layers, you create a shortcut between two distant points. That's basically what a wormhole might be like. Einstein's equations suggest these cosmic tunnels could exist, potentially connecting different parts of our universe or even linking to other universes. While we haven't found any real wormholes yet, the math behind them is solid. The catch? They'd probably collapse instantly if anything tried to travel through them. When two black holes crash into each other, they create some of the most powerful events we've ever detected in space. These cosmic collisions send ripples through the fabric of space-time called gravitational waves. Imagine dropping two rocks in a pond. The waves spread out in circles across the water. That's similar to how gravitational waves move through space. In 2015, scientists made history when they first detected these waves from two black holes smashing together 1.3 billion light-years away. The collision released more energy in a split second than all the stars in the universe combined. These waves help us hear the universe in a completely new way, letting us detect black hole collisions we can't see with regular telescopes. Scientists are making exciting discoveries about black holes every year, pushing our understanding into new territory. The Event Horizon Telescope team recently captured the first ever image of a black hole's shadow, giving us a direct look at these cosmic giants. Researchers are now studying how black holes might connect to quantum physics, the science of tiny particles. They're also investigating whether black holes could be doorways to other universes, or if they might hold clues about how our universe began. Some scientists think studying black holes could help us create new types of energy or even develop better computers. While we've learned a lot, there's still so much mystery around these space objects. Questions remain about what really happens at their center and whether they could help us travel through space in ways we never thought possible. Thanks for joining me on this mind-bending journey through the mysteries of black holes. If you enjoyed learning about these cosmic giants, don't forget to like this video, subscribe to our channel, and share it with your space-loving friends.